Hello students, welcome to the channel. So today we are going to cover some questions which is based on previous year questions with the detailed description. So here we have a first question is that which detector is used in gas chromatography for halogen containing compounds? And the options are: option A is catharometer, option B is electron capture detector, option C is flame ionization detector, or option D is thermal conductivity detector. So which detector is used for the halogen containing compounds? So the correct answer is that is electron capture detector is used for halogen containing compounds in gas chromatography. Let's discuss an explanation about the electron capture detector. So here we have an explanation that electron capture detector is used for the detection of halogen containing compounds in gas chromatography. And what is electron capture detector? That it is a device detecting atoms, molecules in a gas through the attachment of electrons via electron capture detector, and it is invented in 1957 by James Lovelock, which is used in gas chromatography to detect the trace amounts of compounds in a samples. So students, this is all about the electron capture detector. Now moving on the second one detector, that is thermal conductivity detector. It is also known as catharometer, and it is a bulk detector and a chemical specific detector commonly used in gas chromatography. And what does it do? It does that it senses the changes in thermal conductivity of the column effluent and compares it as a reference flow of a carrier gas. So it is a thermal conductivity detector. Now next one is flame ionization detector. It is a scientific instrument that measures analytes in a gas stream, and it is frequently used as a detector in gas chromatography. So students, this is all about this question. Moving on the next question. Sorry students, some technical problem that in this the question is asked that which one is the anti-plagiarism factor. Students, this question asked in every competitive exam or government exam. So as we have already know that anti-plagiarism factor is the niacin. So let's discuss with the help of explanation that riboflavin is for lesions and dermatitis, where niacin is an anti-plagiarism factor, and TPP, that is a coenzyme of vitamin B1, is for beriberi, and pantothenic acid, that is vitamin B5, is known as is for anemia. Students, actually we know about 5 to 6 things in this, that riboflavin is vitamin B2, or TPP is for a coenzyme of vitamin B1, or pantothenic acid is vitamin B5. So try to note down in your notebook. Now the next question is that 3,2-hydroxyethylidene 7-oxo-4-oxa-1 as a bicycloheptane 2-carboxylic acid. Students, I know this is very difficult to pronounce, but this question actually arises in your exam, that is in NIPER. So we have to tell about the names, that it should be a clavulanic acid, or it would be sulbactam, or it would be imipenem, or it would be cephradine. So what is the name of this compound? This compound is clavulanic acid. So let's actually try to learn its structure. Students, this is the structure of clavulanic acid. So please write down or memorize this structure in your brain, because sometimes the question may ask from this part also. Option B is boric acid, option C is kaolin, option D is calcium carbonate. So students, we have to tell about that from in these options, that which one is not used in the preparation of baby powder. So the correct answer is that is boric acid because it contains some cancerous substance. So now next question is, according to Korsney-Karman equation, a 10% change in the porosity can produce, option A is twofold change in viscosity, option B is fivefold change in viscosity, option C is threefold change in viscosity, option D is none of the above. So which is the correct answer according to Korsney-Karman equation? So the correct answer is that is none of the above. Students, don't get confused in these types of questions. So let's discuss with the help of explanation that the question is wrong. Sometimes the question may also ask in this way also, students. So the Korsney-Karman equation is a relation used in the field of fluid dynamics to calculate the pressure drop of a fluid flowing through a packed bed of solid. Students, this is the Korsney-Karman equation. So don't get confused every time. So now coming on the next question, that the containers used for aerosol should withstand a pressure of, we have to tell about the pressure, that at which pressure the aerosol containers withstand. Options are, option A is 130 to 150 psig at 130 degree Fahrenheit. This is the temperature. And second one, option B is 140 to 180 psig at 130 degree Fahrenheit. Option C is 140 to 170 psig at 120 degree Fahrenheit. Option D is 120 to 140 psig at the 120 degree Fahrenheit. So which one is the correct answer? That the containers used for aerosol should stand with the pressure of, the correct answer is 140 to 180 psig at 130 degree Fahrenheit. This is the standard pressure and the temperature. Now here we have explanation part, that the containers used for aerosol should withstand a temperature of 140 to 180 psig at 130 degree Fahrenheit, and it is set by Department of Transportation, regulates the manufacturing and testing specification for the containers used for the transportation of hazardous materials. And the DOT code for Federal Regulation Title 49 Section 143 regulations for aerosols container. Students, sometimes the question may also ask that which CFR or which title is actually mentioned for the aerosols container. So section 143 title 49 is mentioned for the aerosol containers. Now the next question is, in relation to sterilization, what is the meaning of D300 F2 minutes? Students, there is some technical problem, so please try to understand first that death of all organism in 2 minutes, death of 300 microorganisms in 2 minutes, death of all microorganisms in 2 minutes at 300 degree Fahrenheit, or death of 90% micro in 2 minutes at 300 degree Fahrenheit. So as we know that this is the correct answer, but how it will be the correct answer, so we can understand with the help of explanation part. Let's discuss the explanation part, that the meaning of D300 F2 minutes is a death of 90% microorganism in 2 minutes at 300 degree Fahrenheit. So what is D actually? D is D value decimal reduction time. So it is the time required at a certain temperature to kill 90% of the microorganisms, and the population number thus is reduced by 1 decimal place. It is a D value. And what would be the Z value? That it is the increase in temperature needed to reduce D value of an organism by 90%. Students, don't get confused in these values. And at last, what would be the F value? F values, it is the measurement of sterilization effectiveness. So students, try to note down. So now moving on the next question, that which one of the following color is not permitted to be used in drug by the Drug and Cosmetic Act 1940? Options are, option A is chlorophyll, option B is riboflavin, Option C is tartrazine. Option D is amaranth. So which one of the following colors is not permitted to be used in drugs by the Drug and Cosmetic Act 1940? So the correct answer is riboflavin. Now moving on the next question, that by which mechanism the microorganisms are killed by autoclaving? That in this the question asks that what would be the mechanism of autoclaving by which it kills the microorganism. So options are coagulation of cellular proteins of microorganisms. Option B is alkylation of essential cellular metabolites of microorganisms. Option C is stopping reproduction of microorganism cells as a result of mutation. Option D is oxidation of RNA microorganism. So what would be the mechanism of autoclaving through which it kills the microorganism? So the mechanism is that it actually stops reproduction of microorganism cells by lethal mutation. And what is mutation? Mutation is that there is sudden change in the genetic material. Now at last question of this video, so first there is an explanation, students, that it is the autoclave sterilization pressure, that what would be the pressure and what would be the temperature and what would be the time. So if we take the 10 psi pressure and temperature is 115 degrees Celsius, then the time is 30 minutes. If we increase temperature and if we increase the temperature, the pressure is 15 psi and the temperature is 121 degrees Celsius, that is the time for 20 minutes. And the now pressure is changed and the temperature is also changed and the time is also changed. So student, these conditions actually asked in your exam. Sometimes in your government pharmacist exam, the question is asked that at 15 psi what would be the temperature or time for the autoclaving sterilization. So here we have just some short notes on the sterilization techniques and what would be the conditions. So try to note down these conditions, that for dry heat sterilization a minimum of 180 degree for not less than 30 minutes. This is the condition. So try to note down these conditions. And for in dry heat sterilization, actually there is a denaturation of protein and nucleic acid by oxidation. So students, here we have more explanation on this, that one technique is radiation sterilization and one technique is gas sterilization. That in radiation sterilization, what we do in gas sterilization, actually we do sterilized by the radiations, that is gamma and X-ray are ionizing radiations used to cause mutation and destroy microorganisms by stopping their reproduction. And what we use in gaseous sterilization, we use gaseous gases that like ethylene oxide, propylene oxide or formaldehyde, and some more includes covalent bond formation with carbonyl hydroxyl amino sulfhydryl groups present on protein molecules. So students, these are the four techniques, means autoclaving sterilization, dry heat sterilization, radiation sterilization and gaseous sterilization. One more is, students, that sterilization by filtration, in which we use the filters for the sterilizations. And what would be the pore size of the filtration? That would be the 0.45 micrometer. Sometimes the question asks that what would be the range. The range is 0.2 to 0.45 micrometer of the filtration. Now next question is that as per USP, the weight variation for a tablet weighing 325 mg is, and the options are, option A is plus minus 10%, option B is plus minus 7.5%, option C is plus minus 5%, option D is plus minus 2.5%. So what would be the correct answer? The correct answer according to the USP, so the correct answer is the weight variation for a tablet weighing 325 mg is, a student, the correct answer is plus minus 5%. So how it will be possible? Let's discuss with the help of explanation again. So there are two limits of percentage weight variations. According to IP there is different, according to USB there is different, and this is the percentage weight variation. So this is for when we talk about the IP, for 85 mg there is a plus minus 10%, for 85 to 250 mg there is plus minus 7.5%, and greater than 250 mg there is plus minus 5%, and for USB there is different limit, that is for 130 mg or less plus minus 10%, for 132 324%, that is plus minus 7.5%. So students, see the beauty of the question, that what would be the question, that greater than 324. So in question there is asked about the 325. So what would be the correct answer? The correct answer is plus minus 0.5% is the weight variation. So students, I hope that you like the video. So please subscribe and hit the bell icon for getting more updates on our upcoming videos. Thanks for watching.